What's happening, everybody? Hopefully everybody's day is going all right. I am pretty tired, so if you hear that in my voice right now, I apologize sincerely. Working on section 3.3 here, equations with variables on both sides. And our objectivo is to solve equations with variables on both sides. And I will pull up my tools here, and we shall begin. So example 1, the measure of an angle is 5x minus 3 degrees. Its vertical angle has a measure of 2x plus 12 degrees. Find the value of x. So we got to find this missing value, x. We have to use a little bit of vocabulary here. Vertical angle. If you remember from geometry, vertical angles are congruent. What's congruent mean? That means they are equal. So this guy here and this guy here are going to be equal. So that's what we shall set up in an equation. 5x minus 3 equals 2x plus 12. Notice I dropped the parentheses, I dropped the degree symbols. None of that's going to matter when I'm solving for x in this case. So variables on both sides is a problem. Why? Because I want to know what that variable equals. So, step 1, when variables are on both sides, is often to try and get them on one side. So, we got to reverse what we see. I see a 2x here, I see a 5x here. I don't want those on different sides of the equal sign. I want them on the same side. So I'm thinking I'm going to bring this 2x over here to play with this 5x. Well, how do I do that? Well, I can't just move it magically. If I want to get rid of it on one side, I have to make it equal 0. How do I make a positive 2x equal 0? By subtracting 2x from it. So if I do that on the right side of the equal sign, I have to do it on the left side of the equal sign. And I want to make sure I line them up correctly. Notice I've lined up the x's here and the x's here. Do a little bit of math. These two x's are now 0. 5x minus 2x on the left is 3x. Bring down the minus 3. Bring down the equal sign. Bring down the 12. Look what we got now. We started with something a little different. Now we have something familiar, a two-step equation. So quickly solve. Plus 3 plus 3. 3x equals 15. Divide by 3. Divide by 3. X equals 5. Quick check. 2 times 5 plus 12. Hopefully that's equal to 5 times 5 minus 3. 10 plus 12, 22. 25 minus 3, 22. Checked out, works out, confident I have the right answer. You can buy a skateboard for 60 bucks from a friend and rent the safety equipment for $150 per hour. So right away, I'm starting to see an equation there. Or you can rent all items you need for just $5.50 per hour. Or all items are just $5.50 per hour. So that side is missing a constant or a flat fee. How many hours must you use a skateboard to justify buying your friend's skateboard? So let's see, there's a little bit more work here. So x equals number of hours. How do I know that? Because that's what the question's asking. It says how many hours. X equals the number of hours using, we'll call it using skateboard. Cool. So now I want to start to write an equation. $60 from a friend. Is that a one-time thing or does that keep happening? It's a one-time thing. Unless you do it multiple days, but that's not the case. We're talking about one day. And we're finding out how many hours. Plus, how much is it to rent the equipment? In that scenario, it is $150 per hour. $150 every hour is a repeated addition of $150 every single hour. So we indicate repeated addition through multiplication. $1.50 per hour times the number of hours. Well, we want to know when is this going to equal the other situation, which is $5.50 per hour. So $5.50 x per hour again means every hour. $5.50 every hour is repeated addition. Okay. So now we have variables on both sides. Again, I want to get them together. I do not want to move the 550x. If I move that, I'm making more work from myself because now I have one side that is 0 equaling a bunch of other stuff. I want to move the 150x. I want to get it away from this 60, and I want it to have to kind of come over here and hang out with the 550x. So again, I have to move it by canceling it. Subtract 150x, subtract 150x. Gonzo, 60 equals 4x. Last step, get rid of the 4 by division. And it looks like they're the same at 15 hours. So the question is, how many hours must you use a skateboard to justify buying your friend's skateboard? Okay? So what's going to happen after 15 hours? Well, let's take a look. After 15 hours, we can use 20. 20 seems pretty easy. So let's try it. 60 plus 150 times 20. What's that equal? Well, that equals what? 60 plus 30, which is 90 doll hairs. And that's if we buy. That's not the right buy. But I don't feel like rewriting it, so I'm just going to make it look like 2 y's. Over here, other situation, 550 times 20 hours. What's that? That's like $110, I believe. Right? So in the second situation is if we're renting all the items. This is renting. And it looks like anything above 15 hours is going to make buying the bike, or the skateboard, excuse me, cheaper. So we're going to answer the question by saying, how many hours must you use the skateboard to justify your buying your friends? We're going to say any number of hours over 15, you will save money buying the skateboard. One more time, because I'm not going to write that. Any number of hours over 15 would justify you buying your friend's skateboard because it is cheaper after 15 hours. So I'll write a little note. Cheaper to buy after 15 hours. And my penmanship is horrible down there, but I said I was exhausted and I meant it. I apologize. But we got our answer. I think this is the last one. It is not the last one. It says to solve this using the graphing calculator. Well, I haven't figured out how to demo that yet, so we're just going to do it the old-fashioned way for now. Once I figure out how to demo the graphing calculator, I will show you how to do this. So 2.5x plus 1 equals 4x minus 2.6. We're going to go kind of quick on this one because it's the same as kind of the first one. I want to get the variables to one side, so I'm going to move this guy over here. 1.5x minus 2.6. Then I want to get rid of this guy here, bring it over to the other side, because I'm trying to find out what x is. So I'm moving things away from it now. And I got 3.6 equals 1.5x. Last step, divide by 1.5. So 3.6 divided by 1.5 is going to equal something that I will know once I have calculated it on my calculator. 3.6 divided by 1.5. We're going to get 2.4. And at this point, we should probably check. So So 2.5 times 2.4 plus 1, we want to see what that equals, and then 2.5 times 4 minus 2.6, we want to see what that equals. So 2.5 times 2.4 plus 1 is 7. 4 times 2.5 . 4 times 2 point, what the heck did I do here? Something's wrong. All right. Looks right. Hold on, y'all. All right, y'all. I figured out where I screwed up. And I apologize again. So it's right here. This should be 2.4. That's the number we're checking. So this is 9.6 minus 2.6, and that is 7. This is 2.5 times 2.4, which is 6, plus 1, which is 7. So everything's good. I didn't make a mistake in my initial problem. I made a mistake by plugging in the wrong number right here. So hopefully you can learn something from that, because I just did. All right. Last section, last couple of problems. Over on the left, I'm going to start here, and I'm going to distribute the right-hand side. So I've got 4 minus 4y equals negative 2 times 2y, which is negative 4y. Negative 2 times negative 2, which is plus 4. We're going to encounter an interesting little situation here. Why do I say that? Well, it looks like this upon close analyzation. It looks like these are the same things on both sides. So what happens when that happens? Well, let's watch. Let's see what happens if I try to solve it. I go plus 4y to move it from one side to the other. Plus 4y. And I've got 4 equals 4 because this goes away and this goes away. Well, 4 does equal 4. I still do think that. That's probably true. So this is a true statement. What that tells me is that we have infinite solutions. What do I mean by that? I mean that y in this case can be very literally any number you can think of. And you will still get the same thing on both sides of the equation. All right, coming over here on this side, I see 2 variables on one side. Do I go back to my brain cells? Common terms or like terms, we want to group them together. So we got z, 1z, and then a negative 7z. So 1 minus 7 is negative 6z plus 10. And we have negative 6z plus 8. I'm looking at this and I'm thinking, looks like another problem on our hands. It looks like we got something else that's going on here that's a little weird, a little unique. So I'm thinking, all right, what if I want to get the variables together? So I go plus 6z plus 6z. This cancels, this cancels. Now I've got 8 equals 10. Well, I know a lot's changed in recent times, but unless our entire number system has changed, this is false. That is a false statement. When that happens, it means that we have no solution. I can come up with any number in the world and I can put it in for these z's and it is not going to work. Well, I don't know about you, but I've had enough for now. So bye for now. Thanks for joining me. If you need anything, you know where to find me.